to zero waste is the North Star. Every innovation in manufacturing has to be tested against, is it predictive, not reactive, and is it closer to zero waste? If you did that, that's the best you can do. But since then, I've also realized that that AI predictive zero waste has to lead to autonomous systems.
Jennifer, this is a special episode. I think people are really going to enjoy hearing DP, his energy, his analogies, right?
The thing that I love about DP is just the energy that he brings into the love for what he does with the level of skill that he's got and the energy. Just the inspiration is phenomenal.
There's usually two types of people. There's like inspirational speakers, and that is their craft, and it's brilliant. And then there's brilliant engineers who understand deep technical problems, and DP puts that together in a truly unparalleled way. So we move back and forth between like articulating the future in these transformations and talking about specific technical problems.
Yep.
And any specific moments stand out to you?
Oh man, there were so many. I mean, it's interesting. I love some of the things that I really love.
Right, Chihuahua on a bone.
Yeah, the Chihuahua on the bone. The part that's my favorite. That's my favorite soundbite of the month for sure. Some of the things I really loved. High level, I really love how DP is able to draw things to a business use case. What is the problem we're trying to solve? And then go deeply into that, getting integrated in the training, get people into those environments, find technologies and find ways to really, really immerse people so that they better understand how to solve problems, to drive down variability, to drive up predictability, drive up, all of those factors. One of the things that inspired me the most about the time here with DP today was his ability to inspire, but with the level of humility. I loved how many names DP remembers from the people that he has mentored, menteed, worked with, respected throughout his career. They just come out very naturally and easily. It's inspiring.
Yeah, you're going to hear his journey from PhD to IBM to Global Foundries to DP2ventures and kind of core semiconductor and AR, VR, AI. So, okay, let's not hold people back. Let's get into the episode.
All right, let's do it.
Today, we're thrilled to have DP Prakash with us. DP is a recognized leader in R&D and innovation within the semiconductor industry, with over 3 decades of experience at top-tier companies like IBM and Global Foundries. As the global head of innovation at Global Foundries, DP pioneered the integration of AI, machine learning, AR, VR into semiconductor manufacturing. He's now the founder and CEO of DP2ventures, where he's driving AI-powered digital transformation across industries. His work spans everything from predictive analytics to virtual reality tours of nanotechnology chips. And this is one I've been personally really looking forward to. DP, welcome to the pod. It's great to have you here.
Andrew, it's an honor to be here. And many times in life, I go through what's called Forrest Gump moments, where you run into people and you wonder, what am I doing with such brilliant people? Today, being with you, I get yet another Forrest Gump moment. What am I doing with Stanford's fastest PhD, Andrew and Tim Burke? You guys set the pace there, and being with you here, it's one of the, I would say, most exciting moments in my career in life.
That's very kind of you. Let's talk about your career, DP, because it's been an inspiration for me. You began your career in semiconductor manufacturing, where I began my career as well. But you began it in a time when DRAM and embedded DRAM were cutting edge. I guess take us back to the early days when you were starting out, and you've been involved in innovation throughout, but start at that point. What were some of the key innovations that you were working on early in your career, and how did they shape the direction of semiconductor manufacturing at that time?
See, semiconductors, to me, it's touching every field, every function, every industry you can think of, right? In some way, shape, and form, semiconductors is actually influencing it. And that's what excited me about this field. And when I had this improbable journey of getting into the Indian Institute of Technology, which is considered among the finest institutes in technology in India and among the world universities, and then subsequently having an even more improbable journey to come into UCLA, and it's now ranked number 1 in public schools in the country, and to walk around extraordinary people, right? And that all influenced my thinking about innovation. So that's the backstory there. Walking into the UCLA campus and seeing the towering figure of John Wooden, where he talks about competitive greatness, how he won 10 NCAA championships, and then having an opportunity to study under the wonderful Professor Harold Fetterman and getting trained by him, given the freedom to innovate, right? And understanding how to run a lab, an innovation lab, and it's just raising the bar, right? And treating me as someone who can innovate. That's Professor Fetterman. I'm eternally indebted to him. And then if you look at someone who changed my life, it's Grandmaster Tae-Joon Lee. And he actually taught martial arts. And today, the linkage between martial arts and innovation is this. You would hear about the term mixed martial arts, right? So when presented with a situation, it is not the style that you are actually bringing to the table. It is how you're able to mix and match the techniques and be in the moment facing the problem and overcoming it, right? That's the principle. And Grandmaster Tae-Joon Lee taught me how to think about, the martial arts from first principles. Yeah, I continue to be a student. He's now teaching in Luxembourg. These kinds of people coming into my life culminated in the PhD from UCLA and going into IBM, where I had an opportunity to meet with Bob Bernard. I'm in a conference and here I am, a new student, but yet he was asking me questions as though I was somebody, right? And that's what I mean by Forrest Gump moments. And then having the opportunity to learn from him. I said, Bob, you have invented the DRAM, right? And you have invented not only that, the scaling theory, what has actually led the entire semiconductor industry for decades. See, everybody knows Moore's law, right? The idea of every 2 years coming in and packing, twice the number of transistors in a given area. But that was a prediction about how the industry was going to go from an economic standpoint.
Right.
But the person who actually said how it was going to happen through scaling theory, through electrostatic scaling, right? That was Bob Bernard. And to have him as a mentor at IBM, that's how my journey, that's the DRAM you're talking about, the DRAM. Subsequently, Professor Subbu Iyer, he's right now at UCLA, he's an IBM fellow, having a chance to work with him because he was taking the DRAMs and embedding them in the SOI wafers and so on. So it was just an extraordinary, experience working with people who understood first principles, and being with them was in some sense, it's like a bee on a flower, right? Before you know it, 10 years have passed. and so what is extraordinary was learning, from such great giants and working with one of my, mentors there, Dr. Rama Divakaruni, who's no more, just passed away, but extraordinarily generous with their time, coaching and mentoring. And so mentoring is a big part of my journey now, right? Because of this IBM, experience that I have, where everybody worked together as technologists, doing what is absolutely the finest humanity could do. That's what, got me on a 10-year journey that culminated at IBM Burlington, Vermont, with making the Xbox 360 chip. Would you like to know more about it?
Yeah, absolutely. I actually want to talk about that a little more if you don't mind.
Please.
So early on, you were involved in transferring technology between what you were talking about, IBM's advanced semiconductor facilities in the US and Europe. So I want to talk about that a little more. Maybe can you share a story about some of the challenges or wins that you faced during that period, and then maybe how some of those experiences, I'd love hearing you talk about having the freedom to innovate and how important it is for mentorship. Can you talk a little bit more about how that shaped your approach to innovation and technology development?
Absolutely, Jennifer. That's a great question. And I would quote, right, one of the favorite quotes of mine from a teacher, again, another Forrest Gump moment there, Jack Welch, okay? And I'll give you a backstory from there. Jack Welch would say, and here I am, again, running into Jack Welch and having a conversation with this legend, right? Someone who I consider one of the greatest business minds, and I'm not the only one, millions of people feel that way. His passion, the electrifying presence about winning in business just was phenomenal. One of the quotes he used to say is, variability is evil, right? That's an extreme stance to take, but in my mind, it actually says a lot. If I go to Starbucks and I have 10 different experiences and I test across, it's not always the same. And I don't just mean to pick on Starbucks, right? I love Starbucks, but I'm saying many other places you go, any manufacturing place, there is a natural variability, right? So the question is, how do you control it to the point where you meet customer satisfaction? That is the game. And Jennifer, you asked a question about when you transfer technology, what are some of the problems? Now, in semiconductor industry, we routinely have this idea of the R&D, work goes on in one factory, and then, and then that gets transferred to the production facility and so on. So transfers are very, it's part of the routine. But in transferring, you have to be careful about, okay, are the equipment matched? If the tools are different, then why do you expect the same exact result, right? So then the question becomes, well, the tools will be different, and because of practical constraints in business, you're mixing from different vendors and so on, and tools may have been bought at different times and so on. So the question then becomes, you have to work together as a team to understand. See, at the end of the day, Mother Nature works through chaos theory and so on, right? In other words, there are minute changes that have big consequences. So by getting close to Mother Nature, listening to what she says, and being humble about it and saying, look, these are the first principles, and this is what worked there, but when we come here, this is what is changing. So how do we adapt? At the end of the day, Jennifer, it is about, innovation and adaptation, right? You have to innovate and adapt. That's a constant theme that I learned from, from my journey. Certainly, IBM magnified it. What are some of the challenges? The challenges are when there are even the smallest, I'd say change you make, and say, you know what, it's matched that sector. But let's say the vendor could have been, different, and it could be a gas that was changed from a different vendor. It has these unforeseen consequences because processes interact with each other in ways that are not immediately obvious, and only at the end of pipeline do you get to see. And you could have devastating consequences where millions of dollars could be lost because a process change at one point, and there could be 1,000 steps involved, right? Anywhere from 700,000 steps involved in making a chip. And these things can interact in mysterious ways that are not fully always understood, but that is the change that led to this change in yield, performance, reliability. And then you go back and say, okay, if that's taken back, does it actually, recover? So again and again and again, variability, driving it down. And that has been a fundamental, foundational part of my innovation strategy. Eventually, when I went on, right, and we'll talk about that, as Andrew said, the foundational part of my value pyramid, I actually created one for the industry, right, is ability to digitalize the standard operating procedures and make it very rich, make it with text and visuals and so on, and train people to bring down variability. So that was the biggest lesson. And mentoring is very much a part of that whole game. And without people, looking at, the next generation working together. And by the way, mentoring is not just seniors mentoring juniors, it's the other way too, right? Anybody can mentor anybody else so long as there's enough respect. And at IBM, some of the finest mentors are there. And one of the super mentors of IBM was Dr. Rama Divakaruni. And I was very fortunate that I knew him for several decades. And throughout IBM, people like him, people like Professor Subbu Iyer, who's now at UCLA as distinguished faculty, the mentorship is just a crucial part of an innovator's journey.
In the DP, and one of the things I think about me, I helped build a startup accelerator called StartX out of Stanford. And you were reminding me, one of the questions, I hope not spoiling a secret here, an interview question, but a common one we'd ask entrepreneurs is, name 2 or 3 of your mentors right now and what they taught you something. It was always surprising how few people could articulate somebody's name. And you just brought me to that moment. It was like a mark of excellence. You just you have these mentors' names. I don't know if that was standing out to you too, Jennifer, but just you remember the people and what they've done. I want to bring you a question about technology here, because the last answer that you gave to Jennifer, you started with mentorship. You then went into technology and process variations. You mentioned standard operating procedures. You went back to mentorship, and that's something that you move through both sides of these so well. So let's talk about technology again real quick. I want to talk about semiconductor nodes, and I'm going to see if I can get AI to help us out a bit here too. Hey, AI. So we're talking to DP Prakash here, and I want to ask him about semiconductor nodes and more of the work that he was doing at IBM. For anyone on the pod that doesn't know as much about the semiconductor industry, what are the nodes? And maybe you could say just 2 things about the 45 nanometer and 14 nanometer nodes. What are those?
Absolutely. In semiconductor manufacturing, a node refers to a specific generation of technology defined by the size of the transistors used. Smaller nodes, measured in nanometers, 45 nanometers, mean more transistors can fit on a chip, boosting performance and energy efficiency. The 45 nanometer node, popular around 2007, marked a significant advance in chip manufacturing, featuring high-K metal gate technology to reduce leakage current. The 14 nanometer node, emerging around 2014, introduced FinFET, Fin Field Effect Transistor technology,
cool example of how much AI knows and how powerful it is. And 45 nanometer node is special to me because I worked on high K gate dielectrics as well. I wanted to ask you, you were involved at IBM and Global Foundries during both of these critical nodes, which have allowed for the scaling of chips, one of the fundamental things that's brought AI to us today. And you were involved in ramping up product yields, right? The manufacturing side, which I think is now starting to get a lot more attention. Like the design side matters a lot, and then actually building these things systematically. That's been the great championship of semiconductor manufacturing. How did you and your teams overcome some of the big challenges you had at that point?
Yeah, so 45 nanometer is very special. If you look at around, I think it was 2011, 2012 timeframe, you'll remember the Jeopardy champions, the human champions. They were beaten by the IBM, computer. You remember that?
Yeah.
That technology was powered by chips made with the 45 nanometer technology at the time. And I played a small role in one aspect of the technology, right? And of course, the brilliant minds of IBM that pulled it all together. There's a whole team of them and so on. What I'm saying is, in the hardware side of things, when we developed the technology, one aspect of the technology derivatives was introducing the high-K metal gate into a base 45 nanometer technology. Base means you have the standard technology, and then you are introducing the high-K metal gate as a replacement and seeing, right, can you match the yields? And at that time in my career, it was interesting because when I walked into it, I was invited to actually solve a technical problem in 45 nanometer development. And it was, hey, this high-K metal gate technology, when you do it, we run into a problem yields at that particular time. The SRAM yields were on the low side, and they couldn't figure it out for 2 years. And these are stalwarts, right? Major giants and so on. So they said, let's give it to this, this guy. He seems to be knowing some parts of the yield ramps and so on. So let's just give it to him was what it was. And I remember one of the senior leaders who was handling that project said, "You are walking into a quagmire." And I said, almost like saying, "Don't take this," right?
Yeah.
And for me, the technical challenge is much like you, Andrew, right? We love technical challenge. We're like a dog on a bone, saying that, "Give it to me," right? Let's try, right? So what couldn't be solved in 2 years, we cracked it in the next about 6 to 7 months. And what it was imagine a 256 million bits, right, in a RAM, and then imagine about 6 of them. 6 bits will actually be slow in switching. So it's called the slow bit problem that we had. And we couldn't figure it out. Normal failure analysis techniques did not give us a root cause. Every time we cut it and say, hey, everything was fine. And then the thought was in circuit design, you can model transistors as an RC circuit, a resistor and capacitor, right? And if you did that, and at UCLA, brilliant teaching was done there. And I said, look, this is an RC circuit. If you're switching slow, that means the RC part of it. Probably you have a high resistive element somewhere here that you're introducing. And what's the new thing that we're doing? It's the high K. So then we said it's atomic layers, right? Hafnium oxide and titanium nitride, so many different layers, atomic levels are being done for the first time. Something is going on there. Let's go take a look at it. Now, if you're looking at atomic levels of variations, then it's not, standard techniques won't work. So the best and the brightest minds in failure analysis set aside the standard work, and they went about, saying, look, let's take a look at the gate and level by level. And what we found was one of the tinitride, metal layers was getting etched out preferentially, and it was very hard to see, and you had to have a nitride covering over it. And the moment we, looked through that theoretical, understanding, there's got to be a high resistor element there. Go take a look. And they did it. And they said, sure enough, there is this metal getting etched out, high nitrides getting, undercut. And the moment we figured this out, it was like over the weekend, the process team went to work, they created splits, they covered it up nicely with thicker nitride, and they ran a split. Yield just popped from 5% to 70%, and wafer after wafer after wafer coming out. And we met target, exceeded the target. So, and at the time, it was a breakthrough. And executives came over to my cube, congratulated me, and I even remember Gary Patton, was leading. He's the CTO of Intel now. I was leading the project. Came to my office and I had him sign a poster. I said, "Look, you'll forget all of this. Sign this, right?" And IBM's general manager Mukesh Karya was there. I said, "You guys sign this. That this was actually done." They actually signed the poster. We had a good laugh about it and so on. It was teamwork, and you need to bring that intelligence, that insight, and work with the best and the brightest, and inspire. And you really work like a startup. 24/7. And when IBM gets into something, right? The best and the brightest people, like anywhere else in the world. I would say only the fundamental physics can be a stop, not human frailty. So we went through it. It was just such a wonderful story that we could tell from that point on. So we were successful.
The stories are so good, and I want to get to some of your perspective on AI and present day stuff too, but that was an incredible story. So thank you. That's like the dream of every researcher, to be able to actually see the fundamentals going on, you talked about the nitrite cap, have yield jump to 70%. So
yeah.
I loved when you said a minute ago, this is going to be burned into my brain because I love it so much. When you said, give me that technical challenge. Like, we love these technical challenges. It's like a dog on a bone. I get it. I love that so much. So I kind of want to talk about that. I feel like this is so in your wiring. So talk to me a little bit about, when you were at Global Foundries, you led 17 innovation labs around the world that were working on AI, AR, VR solutions. So tell me a little bit about what drove the need for the labs, and tell me a little bit about how they helped advance innovation across the different regions and the different industries.
There's a story there, so Jennifer. In 2005, I had the opportunity to work for this dynamic duo from IBM, two executives. One is, Tom Caulfield, and he was a leader in the executive side on manufacturing. And his partner, right, was the one in R&D, and that was Lisa Su. Now, you'll recognize that these two are, among the greatest leaders right now we have, right? I had the opportunity to work under their direction, and I was given the responsibility to lead the very first Xbox 360 chip production, right, in production. And I had a team, and our team, it was tremendous. We had to compete against, the roadmaps of, let's say, Sony or Nintendo and so on. And Microsoft came out of nowhere. I had the opportunity to remember Forrest Gump, right? I was there. And we ended up as a team, once again, figuring out that it is a N to P, beta ratio for drive currents. That was like keeping the yields down. And it was a decision that was taken once my team detected that. And we actually like fed that back. And it was a decision that was taken by Lisa and Tom to shift the beta and reposition. And boom, yields pop 6 months ahead of target. We met who meets yield target 6 months ahead, right? So we met it, and against a competition for Microsoft coming into the gaming industry. Now, fast forward 2014, right? It is now Lisa, having served as a technical assistant to Luke Gerstner, who turned around IBM, she's moving on to take on AMD's leadership. And Dr. Tom Caulfield comes along. And by the way, both are PhDs, Lisa and Lisa Su and Dr. Tom Caulfield, and good friends too. And so Tom is now in a leadership position in Global Foundries. And I happen to be, I was invited by Global Foundries at the time to come in and work on a $1 billion project. And it led me to this 14 nanometer opportunity. They said, you lead 14 nanometer production. And my team, I built a team from around the world, and the best and the brightest minds coming together. And Lisa came and said, look, my vision is to democratize virtual reality. And at the time, you will see, AMD was just beginning the turnaround journey and so on under her vision. And that was, I remember her coming into Global Foundries saying, let's democratize this. And that's how I got into VR, Andrew. Before that, it was really nothing. So we are making this chip for her, and boom, the production goes up. You can see the AMD stock, 2014-15 timeframe taking off, concurrent to the production ramp and so on. Yet another Forrest Gump moment. And Lisa, says, here is a virtual reality system built out of the chip made from Global Foundries, and said, go, right? Take a look at, what was done. It was a gift, and it just lifted the morale for everybody, because your chip is doing something phenomenal for the world. And very quickly, Dr. Tom Caulfield, being a gamer himself, saw the potential in it and said, look, go play around with this and see what it can do. And me and my team, right, what started out as a demo for virtual reality quickly became, right, by 2015 to 2017 timeframe, very quickly we realized that this is a technology that will be transformative. But enter, PTC's Jim Heppelman, CEO, and Professor Michael Porter from Howard. These folks were already ahead, realizing that the 1,000 times bigger cousin of VR called AR is coming in, and this is once in 300 years transformation in manufacturing productivity. This is Professor Michael Porter saying this, right? He understands, looks across industries, and look, across 300 years, I can tell you this is a transformative play. We understood what VR can do, and we understood now what AR holds potential for. But then Tom, my former boss, Dr. Tom Caulfield, CEO of Global Foundries, he walks into that lab. By now, that demo room has become an innovation lab, right? It is a very natural flowering, a blossoming of innovation. And suddenly people are so excited by it. People are coming and seeing. Then Tom comes in one day, and I credit him with this, right? Andrew, he says, look, AI ML has to link to AR and VR to reach the highest value. And that is why in the lab, we actually had the lettering there in the lab was AI ML AR VR. And you came into that. And that's when Andrew enters my life.
Yeah.
Right. So Jennifer, I don't know if I answered your story there. The point is, it was a natural, I'd say a journey where virtual reality chips coming in and teaching us like what is this visualization aspects of it. We're thinking about computing in a certain way. The idea of the roots of spatial computing was born. And we realized something totally special is going on. And that lab became a very popular place. In fact, people would say, it is the most attractive, place in the company. And out of that, every factory, right, Burlington, Vermont, or Fishkill, or Dresden, Germany, or Singapore, and even in the design team sitting in Santa Clara, all these folks, they all wanted their innovation labs. And as we were, ramping up our own innovation labs, everybody could start playing around with these technologies to really drive productivity. And how we make the chips can actually change. That's the idea, right? But when we're doing this, the universities and school systems that were surrounding us were also interested. And there's a lot of excitement there. That is how the total of 17 innovation labs came about. And it was just wonderful to see everywhere we go, people getting into it and powering it, people of IBM, people of Global Foundries, top-notch innovators getting into it. And from there, when I subsequently started my own company, I had 2 other clients using it. One of the clients, an amazing client from Pennsylvania, and she actually just embraced it. And I had a chance to work with Ray Ozzie, who's the former CTO of Microsoft, and he is right now CEO of Blues. And the idea of bringing, the sensors, right, IoT, and working, integrating that with manufacturing, connecting that with networking, and then going into the cloud and edge, and coming into the analytics aspects of it with AI, and linking that to AR and VR, closing the loop, just lifting the game and drive 10x higher, from a ROI standpoint, from a cost standpoint, from a reliability standpoint, right? And just the ease of innovation, right? We did this, and Ray was kind, and he asked me to demo in the Consumer Electronics Show in 2023 as part of his 10 brands from around the world that he recognized. It was, again, a goosebump moment. That was like the Forrest Gump moment again, Andrew, saying, what am I doing here with, the great Ray Ozzie? And he is the one who invented Lotus Notes, right? He invented Azure and so on. So for him to say, bring down the friction in collaboration, that is the highest level. I recognize the immense potential. And that became the motivation for my current company.
Yeah, this is this amazing arc, like I said, the AI, ML, AR, VR, and then this arc all the way to your current company, which really want to ask you about. But let's go back. So Global Foundries, like you said, this is the moment that I got the privilege to walk into your life. And I remember walking into that lab and seeing the slogan on the wall. And one of the things that struck me really deeply about our first meeting, many things, but there's some people who are just amazing at technology, heads down, and they do real use cases. That's really impressive. And there's some people that can articulate innovation and a future vision. And there's very, very few people that put those two together. And I remember I walked into your lab, and I didn't know the history. You'd already made so many deep technical contributions. I knew them. I saw your LinkedIn, but I didn't really know it. And I saw the slogan, and you started articulating to me innovation and vision, and I was blown away by the way you articulated it. And then you started going into the use cases, and this might seem subtle, but you went into your pyramid, I'm sure you remember, of use cases. And specifically, you point out, and I, because you were so good at articulating technology, I was just assuming the first thing you were going to point out as a use case was some kind of totally futuristic sort of out there thing. And instead, you start talking about leveraging AR and VR for reducing training times and work instructions. And you go into this extremely practical use case that's creating significant value that now a lot of people take for granted how fundamental this was. And just for me, that was this moment where I was like, okay, DP is the kind of guy who both understands the future and he understands the path to get there, which I think is a really rare skill. Like I always say, it's easy to predict the future. what's going to happen, just not when. It's like eventually we'll have AGI. Great. When exactly and how, right? That's really hard to say. And so I guess, could you go to that moment, like share a little bit about that use case in particular? From my perspective, a standout achievement was, leveraging AR, VR to reduce training times, improve factory efficiency. It's something that some people take for granted now, is of course, this is one of the great use cases of AR, but you were the first person I ever heard it from. I think you were one of the first people doing that anywhere.
You're absolutely right, Andrew. And as I said here, right, we had the vision of Lisa Su. We had the greatest manufacturing leader on the planet, in my humble opinion, is Dr. Tom Caulfield, right? He understands what's happening on the floor, and these kinds of people and a team, and nothing happens without a team. And there are several team members that I have that are absolutely phenomenal. And given a challenge, Jennifer, just like you said, right? Not just a dog and a bone. Imagine a chihuahua, a small little dog on a big bone. That's how innovators look at the opportunity. Bigger the problem, oh, then great, let's go at it. We can be gnawing at this for a while. So, but go back to the fundamental principles here. The reason why I'm saying all of this is that it takes an ecosystem. It is, right? Certainly, I had a role to play, and people have always said energy and enthusiasm, right? Andrew, I've heard this, all my life, right? From 5 years old. Energy and enthusiasm. You're bringing that into the mix and saying, look, what is possible, right? What is possible? Can we do this better? And just appeal to the logic of it, and say, like, look, from a business standpoint, look at what my mentor, right, Dr. Tom Caulfield himself, right? He would ask the toughest questions. And I would say, look, Tom, we can actually walk inside the chip now. We can walk into the factory. We can walk inside the tool. No black boxes. Silos are gone. This is an unbelievable productivity play. And now I can walk inside the chip.
That's a real one, too. I saw it then.
You saw it, right?
I remember.
So we were like asking questions, and the team was responding, right? You have to say, can you do it?
Can I highlight it though, DP? Because again, I hope people listening can get this, because you say it so fluently, it makes people think. But like, I was there was like, well, I'll walk inside of a chip. What is this big idea? You literally had one. You put on the headset and you would go inside of the chip, the multi-layer vias, and suddenly this like abstract, complex physics principle became common sense to you, and everybody was understanding what the actual architecture of the chip was and what you were building, and it improved their work. And it's like the VR where you go inside the human body now and you can understand the body so much better. And you were doing that for a chip for practical business value, like right then, right?
That's right. That's exactly right, Andrew. Again, I cannot say enough good things about my former boss, my great mentor in manufacturing. He would come in and challenge me and said, okay, you can walk inside a chip. I get it. Where's the ROI? The thing is, when you raise the bar continually, right, that is critically important. As the coach does that, you can actually continue to keep going in that direction. But what I learned from Dr. Caulfield, the most important lesson was this: any manufacturing CEO, right, lives by an iron law. It's called gross margin improvement. It's very simple, right? But yet most people miss it. The gross margin, profit margin, is revenue minus cost, and revenue for a manufacturing entity, doesn't matter what kind of manufacturing you're doing, is price multiplied by quantity. It's P times Q. And then if you look at the gross margin, M equals P times Q, revenue minus cost, right? It becomes an M equals PQ minus C play. It's a PQ minus C play. That clarity that, Tom actually taught me, I'm eternally grateful for that. Why? Then it helps you understand, how the best in the industry actually works. TSMC, for example, how are they increasing the revenue? They're increasing their price, right? How are they doing it? They're innovating. So if you innovate, you can increase the price. If you don't innovate, price erodes. If you look at the quantity, if you want to max out the quantity, you have to have all the tools running. If you want to have all the tools running all the time, right? Because remember, a plane doesn't make money when it's on the tarmac. It makes money when it's flying. Same analogy. Tools have to be up and running. If the tools have to be up and running, then the people running it have to be top-notch, right? They have to understand what's going on. Degrees are secondary, right? Do they understand? Have you given them the tools to understand beyond the black boxes? Look inside. That is the journey. TSMC, if you look at it, they have PhDs that have to be trained for 2 years before they're allowed to touch a tool. Yeah. And such deep training can actually mean before an excursion occurs, the variability, Jennifer, we're talking about, before a variability occurs, it's prevented because people are making decisions, right? And this is what Sun Tzu will say in martial arts, right? The best battles are the ones you win without even fighting. So you bring that, like that spirit into it, and the training parts of it, right, can be like, turbocharged, and the AR and VR aspects of it training as a killer app. Look, many people say metaverse came and went. I'll tell you, in my humble opinion, metaverse is a solid play, right? It's going to be for the long term, simply because you just look at nature's intelligence, right? AI is artificial intelligence, but how long have we been playing around with it, right? Since 1950 to 55 timeframe from MIT, Dartmouth, that meeting and so on. Look at nature's intelligence. We all are designs of nature, and we've evolved over 13.8 billion years, right? It took time to actually get there. Ask this simple question, Andrew, just like, the triangle, the pyramid you saw and so on, right?
Yeah.
One of the realizations for me as I was doing this was, just think, why is it the dominant species on the planet today, right, in its various forms, we have the eye, the vision engine, leading the much bigger brain. It's the vision-led computing, right, that is going on. The reason why that happens is, if I can't see what is ahead of me, I can't adapt. But if I can see it, the brain can actually do things to help the entire organism survive, right? So the vision-led compute, I see as the obvious thing from my side, that it is going to come up. That's the so-called spatial computing that Apple says. That's why Zuckerberg changed it to Meta. These are not people who are just doing it on a whim. Once we see what is possible at the cutting edge, Andrew, for example, bringing up an augmented reality experience in the empty space of a highly complex environment next to the tool, once you see it, you realize this is the future, because the learner is now not dependent on the one human coming, the coach, right? Sure. Coming in and talking for 9 months or 10 months and shouting at 35 decibels past. That part of it is there, but we can do better than that. Allow the learner, get the obstacles out of the way, let the empty space come alive. And they can train, they know what the next steps are, and they can be self-learning. And suddenly what happens is their time to proficiency just steepens up. And not only that, the level of understanding also increases. Yeah. So that ties to the business outcome. Remember quantity? Quantity has to be shipped. This is how it ties to outcome. So when you tie the innovation actions to the outcome, that becomes sustainable. And this is why, they say PQ minus C guides all actions, right? I give credit to Dr. Caulfield for guiding our innovations that way.
Dr. Caulfield is amazing. I want to build on this just a sec, and then Jennifer, take us forward to AI as well. But I just want to build on this for a bit. So you described the training use case. A lot of people talk about tacit knowledge these days, like in the expert's head. You talked about 10 months to train somebody. And this was in, what was this, like 2018, 2019 or something? And for me, again, I think you were one of the first ones using it. And I guess I want to emphasize too, in the Global Foundries semi-fab, everybody today is talking about the silver tsunami and that experts are retiring. There's not even a person there to train you. And so it's becoming extremely urgent. You talked about the eyes, new AI technologies letting us capture our voice, capture pictures, capture, use glasses, capture rich media to train people. But you were early to this, and Global Foundries had many experts, but one, you talked about how the fab is loud. The other thing is that you have to suit up. It takes a long time. It's a clean room environment. And so there were these other economic factors that just getting into the room takes a long time. It actually takes a lot of money. And so without being able to go into the room and have the virtual experience of start training, it was creating significant ROI in a particular environment that now I think a lot of other places have the ability to emulate. They don't have a clean room. They don't have that specific challenge, but they do have the 10 weeks, 10 months to train people. They are starting to lose experts, and they get to have the benefit of some of the things that like you were pioneering in these really intense economic environments. I think now is starting to become a lot more common. So I just wanted to highlight some of those factors, because I think these are some of the reasons, again, like the walk inside the chip, but ROI, it let people understand specifically what they were building. And this was like the training for AR use cases, but also the not having to suit up and go in the clean room, and the reducing time and the volume, right? That all comes together to make it a high ROI use case, like right at that moment.
And I have to give credit to you, Andrew. Yes, we're working on zero downtime. We're working on increased collaboration. We're working on the experts, right? The knowledge actually retained, right? And this collaboration can be improved between experts and the juniors. All of that stuff, AR is a game changer. AR and VR, there's no doubt about it. Killer app for AR and VR and metaverse is training, period. You actually see it, right? And I see that having impact way beyond just semiconductors itself. It changes the game of training across every industry. That excites me a lot, right? But I have to give you credit for one thing, right? I was working on the zero waste concept, right? Zero waste. Just think about that. At Global Foundries, the standards are always high. IBM Global Foundries. And they'll say zero defects mission. Like, how do you drive zero defects when Mother Nature has all these, like, these changes, the variability that happens? But it was asymptotically the right direction to go into. If you say zero defect is my mission, what you ship to customers should be, zero defect. That's the idea, right? So when we are working on zero waste, that part of it was clear to me. But working with you, Andrew, I have to tell you this, right? It was a goosebump moment, yet another forest moment for me, as I just said, right? Working with you and Tim Burke, the fastest PhDs from Stanford. I still remember, because what you did was you took the zero waste and said, no, it's zero waste, but it has to be AI predictive first. And we said, aha, AI predictive zero waste is the North Star. Every innovation in manufacturing has to be tested against, is it predictive, not reactive? And is it closer to zero waste? If you did that, that's the best you can do. But since then, I've also realized that that AI predictive zero waste has to lead to autonomous systems. So that is where the next, with all the generative AI coming along, that's where it is. But the idea of the prediction and what you did was, and I have to say this, I have to give you credit for it, is because you changed the game for the prediction engines. When people said, you know what, in that case, like, in 2018, I think, right, you and I, right in that time frame, 2018, 2019 time frame, we're working together. And the idea was like, look, vacuum pumps, so it's a simple little, gadget. It drives all these tools and so on. And thousands of them exist, and hundreds of them will die a natural death. And that's called run to fail. And then you replace them. But is there a better way? This is what the leadership was asking, right? And is there a better way? And when you and I talked, I said, Andrew, what can be done? And you said, show me the machine. I'll tell you what the right data to look at is. And instantly, right, that was music to my ears. And I said, this leader understands what the pain point is. And then you came in, and the way we did this, right, Andrew, you'll remember this, the idea of physics. I've never seen an innovation collaborator who would come along with me. And once I pointed out the problem, you were like a bee on a flower, right? You were just looking at all the aspects of the machines and like asking questions. You came up with a physics-based model. And that was the first part. That's the intrinsic fail mode. Then, we said, what, that explains 85% of the problem. But we said that's the extrinsic fail mode, how it's being used. Then you came up with the supervised machine learning on top of it, right, to monitor. And then we slapped on the unsupervised machine learning. And between those four, intrinsic, extrinsic, supervised, unsupervised, we got it. And people couldn't figure out like why we could crack in six weeks. It's because I had the fastest and the best minds on the planet, Andrew and Tim and team from Arch working with me at the time. People said, no, it's a fluke, right? No, it's a fluke. You predicted it, but it's a fluke. And I was laughing, saying that like, this is Mother Nature's first principles. And they said, okay, it's a single wafer tool. Now predict a 25 wafer tool. And of course, it was successful. And the team actually rose to the occasion, and it ended up saving like significant amounts, winning awards and so on. So Andrew, AI predictive, zero waste, autonomous systems, this is where AI is taking us right now. And you are a pioneer in the space in manufacturing, in my humble opinion, a great innovator to work with.
I mean, I have to jump in a minute. All I heard in that was him talking about working with you, Andrew, and solving some of these problems. I'm sorry. All I heard was the bee on the flower. All I heard was the chihuahua on the bone, just going for it. Sorry. But I actually I want to bring it back, because I think that there's something here that's so important. And of course, naturally, I'm a business communicator by training, right? So for me, what is the business use case? What is the business use case? The hyper focus on the business use case. And we know that manufacturers, especially, high yield manufacturers, they need to produce more things with less resources per thing. That's the job. That's what you have to get out the door. And so I want to talk a little bit about, in some of these use cases where we are enabling, or where this technology is going to be able to enable higher yield, better predictive maintenance, some of these things that AI is just so ready for this challenge. I want to actually talk to both of you a little bit about that. How are we solving these together?
I just wanted to say about that. First off, thank you, DP, for the AI predictive zero waste tee off. One of the things I love about that example of what we worked on together is a lot of people, when they think predictive, they only think predictive maintenance, and then they only think predictive maintenance leads to like saving a part or stopping a downtime, and it does. But I think one of the things, especially in high-tech industries, is that predictive leads to zero waste, AI predictive zero waste. It actually has to do with yield and scrap. It's extremely valuable. What we were doing in that use case, you talked about the pumps, like taking all the parameters, how we did a physics-based prediction, and then we did this unsupervised learning to cover all the use cases. But the reason it was so valuable, back to Jennifer's tee up on use case, was when these particular pumps failed, air would enter the system. These are vacuum systems for semiconductor processes. They need to stay completely clean. And so if this pump failed, it wasn't that it was just down for 30 minutes till they could swap it out. It was that air would come up into the tube furnace and contaminate the wafers, and we would have to scrap an enormous amount of wafers, right? And then when you're looking at etch systems or others, there were similar problems of like, what's the collateral damage of a failure? And I find actually that that's a lot of what's valuable across our high-tech use cases, is how maintenance directly interacts with quality. And I think that's something, back like your training use case, like not being able to go into the room, the suit up. It's like when you're in the space and you understand these specific things, you get down from the generic to like exactly how a maintenance problem directly relates to yield. So that's the thing that was kind of standing out to me about that use case that we worked on together. And again, some of the stuff that when people just stay at the generic level, they miss, and why that phrase AI predictive zero waste actually fits, perfectly together.
Beautifully.
What would you say, DP?
Yes. So Jennifer, if you look at 100 years from now, what will matter, right? And it's not going to be, if I may share my perspective, it's not going to be getting lost in the lesser, concerns, right, of man. It is how the best minds of the world, right, have, and I say that with openness, democracy, right? Everybody can actually innovate. That's my humble opinion. Coming together and solving problems that really, truly matter, right? Now, how do you measure success? In any manufacturing, the success, right, 100 years from now will not change. The success metrics won't change. I believe so. And here's why. Number one, what is the most important metric for any manufacturing entity? It is safety, right? That won't change. That didn't change like 100 years ago for Disney. It was number one. And in fact, you can see the Disney skis. Safety was number one 100 years ago. It didn't change at the time of pandemic. It became even more important. It will not change 100 years from now, right? So understanding when technology changes, what doesn't change is business outcomes is important, right? Safety is first. Second is operations efficiency, right? Every part of every business, every firm, and every function has to relook at the workflow and come in and say, with the current capabilities with AI, digital twins, and the associated, building blocks of innovation, there are many of them, right? Can we reinvent this for better efficiency? This rewiring has to fundamentally occur. Workflow efficiency improvement is what AI is actually transforming. So that's the operations efficiency part. By that, I mean quality, I mean first time right, I mean tools always up. All that stuff is then operation excellence. That's the second one, operations efficiency. Third, that's not enough. You have to have a competitive advantage. You've got to do something. And the question then becomes, what is the use case for competitive advantage? Then you say, well, look at all the standard operating procedures. Can we do that better? Can we just, instead of text-based, can we make it more visual? Can we make it a lot more interactive, immersive? And so we innovated that in the e-times interview and so on, pioneered that in that space. So that is one area where between GF and PTC, we had worked together and so on, and credit to, the PTC team and the MIT, colleagues there and so on that are there. So that's the one use case. Standard operating procedures. Remember, variability is evil. Make that far better. Don't just go with the text-based cognitive overload. No, that's one. Second, training, right? We already talked about this, AR and VR coming in. Now with AI copilots, right, and the visual. Remember what I said? It's the vision-led. It's the eye-brain metaphor, the digital twin, and the AI compute coming together. This is why it's going to, it's inevitable. What Zuckerberg says, what Tim Cook says, and so on, it's inevitable. Spatial computing, Fei is doing some really good, good work with World Labs and so on. That, I think, that's the operating system. So there is training that's going to be, redone. Jennifer, my humble opinion is what Semiconductor's teaching us, the front runner. The pace is, relentless. What we are setting in semiconductor industry sets the standard for every industry in terms of training. Training goes up. It becomes democratized. And that's a phenomenal thing. And when people actually are better trained and you can do things faster, then you can go towards zero waste operations. And that's when AI comes in and says, okay, I'm making things efficient and I'm going to be predicting things for you. I'm going to become a co-pilot. Then you say, you know what, AI, come in, have a seat as a co-creator. Look at Andrew coming and bringing AI in. AI is a co-creator, but humans one step ahead. I believe, my opinion, AI should work for humans, not the other way around. At all times, humans should have the oversight and the responsibility for the business outcomes, right? So at the AI predictive, zero waste, autonomous, systems, but the creative humans at all times having a sense from first principles how these things work. That's why the observability in AI is very important and so on. So the use cases are incredible, Jennifer, but the fundamentals don't change. It's a PQ minus C play. It's very predictable. Yeah. What is the maximum theoretical you can do? Price times quantity minus cost, right?
I think that's really important. Talking about it enabling, like you said, it enabling innovation and enabling these next steps of it. It's funny because you've heard me say this before. There's that old saying that I want AI to do the dishes for me so I can be creative, not the other way around, right?
Exactly.
I want it to enable me to be able to do what I do well, not the mundane. So, and I think that's true. I want to talk a little bit, though. I mean, we could do 17 episodes talking about your career. It's fascinating. I want to pivot just a little bit, though. We're talking about using AI, digital twins. That's a pretty heavy focus right now with DP2ventures. So you want to talk to me a little bit more? Tell us a little bit more about what your focus is going forward.
So Jennifer, thank you for that opportunity. I would say, one of my mentors, right, among the many mentors that I have, is actually Thomas Edison. If you go to New Jersey and you see his invention factory, you can't help but get goosebumps. For somebody who actually has done some innovation labs and so on, Edison just looks a giant, right? And what he did, he solved high impact problems. And, at some point, you have to ask yourself, what is your purpose? What were you born to do? And for me, my purpose is to elevate humanity to full potential. If I can help, any person or any company, any CEO grappling with a problem, if I can bring an innovation toolkit where AI and digital twins play a central role, but they're not the only ones. They are playing a central role. That's the eye and brain. That's why I firmly believe, right, that is happening. But you should have the idea of IoT, right? That's what, Ray Ozzie is like pioneering, work there. You should have the network aspects of it. You should have the edge computing along with the cloud. There's a stampede now back to the edge, right? You should understand that part and bring that to the equation. You should also look at the data lakehouse. If you don't have all the data as a single source of truth, you cannot have AI powered. So how do you bring that in? That's foundational. Then you have the generative AI stack. Then you have the spatial computing with AR and VR. Then you add on top of that the software engineering and the systems integration, finally cybersecurity, and wrap it up. Now, these, I believe, are building blocks of innovation. And that is where DP2ventures is driving. Out of the 19 innovation labs that I've done, I've observed patterns. I've seen C-suite leaders, they don't have time to do this. So I become the innovation whisperer, right? Saying that when they come to me, and that's how I even got started, because when pandemic struck, and my director friends at Region Ron who had seen my work came and said, hey, people are dying, come save the planet with us, right? I had to make a decision and say, you know what? My job is to help the leaders of innovation, right? And assist them with innovation assistance that they themselves may not be able to get to. So in 2 months, I showed them what could have taken them 2 years. They ended up doing great work. They're a great company anyway, right? I had a small little role to play, but they ended up creating the monoclonal antibodies and saved, the life of the president and so on. But they are on the journey, right? People like that, when they ask for help, to be able to be there. And I want to do that for particularly small, mid-sized businesses and big companies too. One of the biggest companies in design comes and says, look, we are working on the chip design. And it takes about 36 months for a new design for, let's say, 2 nanometer, and takes 18 months. Can we compress that by a shorter time? And you take a look at this, rewire the whole thing. Yes, you can ship twice the number of chip designs from start to finish, design to delivery. You can do that if you are bold enough to experiment with generative AI on specific steps. But it's not a simple problem because there's hallucinations, other things you need to work on. This is why I exist. This is why, DP2ventures exists. I exist for orchestrating innovations for a thriving planet. So be it an individual who comes to me for mentoring, be it a small size company that comes in and says, look, $100 million company, and I have this vision of a smart factory, and being able to put together the whole thing, and being able to do that rapidly in an unbiased manner and building the innovation muscle of the home team, right? I really want to see manufacturing thrive, right, in the USA and all over the world. And so when people come to me, I take that essence of what I've learned from semiconductors and give it to them in a way that's accessible, and so people can actually grow to the next level.
So excited for DP2ventures.
Thank you, Andrew. You've played a role in my career, and you've helped me here. And I would say, Jennifer, 100 years from now, what will change? Safety, operations efficiency, competitive advantage, customer experience, sustainability. These 5, right, are the North Stars. You have to look at every innovation and then look at the use cases, better standard operating procedures, reduce the variability, get the training done, and get people excited about learning the next one. Imagine the silos getting busted. Imagine no black boxes. People can recursively ask questions. What is there in this Tesla? Well, that's an induction motor, and it has 3,000 chips. What's there inside the chip? Well, it's a TPU, it's a CPU, it's a GPU, or a ASIC. Well, what's inside that? Well, these are the different blocks. What's inside those blocks? Well, these are the different, it's a PLL, or it's a SerDes, or it could be SRAM, it could be a random number generator, right? All these different blocks, amplifier, all these different blocks. Well, what's inside that? Well, these are devices. It's a MOSFET. It's a PN junction. It is a HBT. It's a in a quantum computer. It's actually Josephson junctions. How many people actually will know what it is? AR and VR are coming in to shed light on it. So anybody, it doesn't matter what field you're in, where you are, a 6th grader can appreciate the beauty of what's going on in the nano world. So man walked on the moon, right, in the 1969 time frame. With my team, I had the privilege of seeing man walk inside a chip, right? When humanity comes together, works together seamlessly, we set the bar. 100 years from now, that's what will matter. All of us are recycled atoms. But what will matter is that generation waking up and said, those people had a vision. They worked together, came together, solved important problems, and when they handed the baton, they did a darn good job, right? So to me, that's why I call it innovations for a thriving planet.
Okay, DP, rapid fire questions here. Is there a book, movie, or TV series that inspires you in thinking about the future of manufacturing?
Winning by Jack Welch. It's a book every leader should read. And the reason why I love that book is Jack Welch talks about bringing every brain into the game. And that, I think, is what innovators should do. And you can look at it in a small lab, you can look at it around the world and so on. If we can bring the very best thinking and actions in, what kind of problems can we solve, right? That is why I like the word winning. I think everybody should win.
That's awesome.
If you look at a movie, if you want to ask a movie, Ready Player One, Steven Spielberg gives us a very accurate portrayal, right, of what is coming. Of course, there's artistic leaps that they take, but the idea of physical and the digital and the biological systems merging, it's inevitable. This is the direction where I see the future. It's evolution of humans itself. There's a lot of responsibility on technologists to ask the right question. We have to ask ourselves, what is success for humanity? But the opportunity is in front of us. Physical, digital, biological systems converging. You can call it Industry 4.0, but what you see in that movie, right? Even the form factor. I love the form factor. Just, plop it in, and now you can see the glasses are coming along, Meta just released and so on. The form factor, not clunky things, but really simple. At the end of the day, it helps you to do, see more and do more. So that's why I like those.
Do you have a leader or innovator in technology or engineering that you admire the most? And if you do, why?
A leader in technology that I admire greatly is Dr. Tom Caulfield. The reason is he started from a family where it was a fireman's family from New York City, went through Columbia University and then PhD in material science. And he could speak what is important on a manufacturing floor with passion. And he could switch to Arrhenius plots and talk about quality issues and so on. And the range of disciplines he's able to bring together, somebody who I think loves humanity, right? Loves innovation, loves humanity. As I said earlier, this was a forest moment for me. How did I have an opportunity to work with such a great mind like that and get mentored, right? And so I have many, inspirations. He is one of them. I would also say, hey, Charlie Chaplin is another one, because on one hand, TJ Watsons of the world, amazing leaders. They came up with the concept of think. You can solve every problem, and I'm eternally grateful to IBM and TJ Watson for creating the opportunity and becoming a world treasure that IBM is. But Charlie Chaplin actually reminds us that we think too much and we feel too little. So humanity is needed. We have to work with machines, but we shouldn't become like machines, right? So have AI co-creator, but lead, and let there be more laughter. That's what Charlie Chaplin said. And that's one of the reasons why I believe in any innovation lab, I actually measure. Are we smiling enough? Are we laughing enough? Is everybody having a good time? And Dr. Tom Caulfield, one of the things I learned as I got mentored from, I was his technical assistant and chief of staff. And what I learned, is he was having such a good time. I said, hey, here we are busting our, our rear in the yield and performance, reliability, and so on. And people are so tense on this side of the building. You go to Tom's office, and people are having a wonderful time leading, and he would laugh so much and so on. That is one of the most amazing things. So you see the connection to Charlie Chaplin, right? Yes, think, but also have a really good time. And at the end of the day, if you look at what Dalai Lama said also, a better world, right, is a happier world.
DP, what piece of technology outside of manufacturing has had the most impact on your life?
I'm going to give you the answer to this one, but it's not my original. It is my friend Umar Arshad. He's from MIT, and him and I were walking along before giving a talk to the semiconductor industry on the Fab Owners Alliance. We were saying, look at Phoenix. And he said, you know what? Who are the greatest innovators? And Umar asked this question to me, and I was blown away by the answer. And that is, he said, children. Children are the greatest innovators. Why? Because nobody taught them how to walk. They are crawling, they're walking, they're running, and they seem to be falling down, getting back up. And they're able to learn with so little. AI needs so much data, but children, you don't need too much more. They understand the context. The greatest technology I see in front of me are children. And the greatest job I ever had, I believe, is being a dad to my kids, Manav and Janavi. And every day I learn how that supercomputer, right, that works inside their brain. So to me, I'm thrilled by humanity. Yes, I'm a technologist. Yes, I've worked all my life as from the finest institutions in the organizations in the world as a technologist, but nothing comes close to seeing the technology of children, what's going on, with them and becoming. That's why I always say you have to connect to the inner child within you. For every innovator, it's play. Children teach us it's about play. So to me, the greatest technology, hands down, children.
If you could instantly acquire any new skill or knowledge in any area, what would it be?
It would be the skill to learn any skill 10 times faster. And that's, in fact, one of the areas I'm not wishing for. I'm actually working towards, right?
You wished for more wishes. Yeah, but that's good.
No, the thing is this, any skill to be able to learn 10x faster than what's possible today, it's coming. I say to people, right, that you can actually learn 10 to 100 times faster. It scares them. So I don't want to scare people saying that you can learn that fast. It is coming. AI coupled with the AR and VR, the extended reality technologies, it is coming. Anybody can learn any topic 10 to 100 times faster. All they have to do is look and ask, right? The system is going to respond, and the humanity's full potential is going to be released that way, right? So I am wishing for that. And the training aspect, being a killer app with AI and XR, is moving in that direction. And I'm actually pioneering. So for my clients that are coming to me, we are working on some exciting, I'd say training methods by which we can open up the world and let there be more Einsteins, more Marie Curies, and let there be let millions of flowers bloom, right? And what is holding us behind these unnecessary steps, right, that are holding humanity back with technology, with AI for the good, right? AI and extended reality. That is, remember, I always say this, the eye leading the brain, that's working together. Digital twins and the AI working together. This is what I see. You could also say that's the greatest technology that I see, coming ahead beyond children, right? This is what I see ahead. I think in our lifetime, we're going to see some pretty amazing, unleashing of creativity. Degrees, the thing that hangs on the wall, right, goes obsolete, fairly quickly. But it is ultimately it boils down to one thing. It is not where you went to college. It is what can you do now? What can you do now? And if you're able to do now by being a self-learner and using these technologies and come up to solving problems, welcome. The door opens, right? And that, I think, is going to open up to a much better world.
I feel like you've answered. I wanted to ask you one final question, which is, you've kind of given a core of it already, but how would you cap it up? What advice would you give to young engineers entering the field today?
I get a lot of mentors, right? A lot of mentees coming to me from different stages of life, Andrew and Jennifer. People coming from the early stages in high school, coming and saying, like, I have one, a mentee from Belgium, and she's in the 10th grade, and she says, her name is Mika Samvedam. And what she says is, hey, how did you find your destination purpose? And how did it appear when you're in the beginning of the journey? Was it a straight line from there, or was it ziggy-zaggy? What a wonderful set of questions. Those are Mika's 3 questions that I think will be timeless. And I see people coming into the, hey, I finished a PhD and I am now working, but I am completely unhappy. And for this reason, what should I do? So this is a topic that actually Susie Welch, right? Jack's, other half, Jack Welch's other half, right? So she's doing some pioneering work. The concept is becoming you. So what I tell all my mentees is, find what is your passion, find what your skills are that would be valuable in the marketplace. And those 3 circles, passion, skills, and market value, when those 3 intersect, that is your area of destiny. And so to go in that direction and to say, look, if you look at Bronnie Ware's, really pioneering work on what are the top 5 regrets of the dying, the number 1 regret of the dying when you're in the hospital and observing is to say, look, I did not have the courage to honor my dream. Right. So I tell all my mentees, wake up. We are all recycled atoms, right? Just having this blip of life. Before we become recycled atoms again, you have to find what is it that you want to, what you value the most in life and go after it, full bore. And in that process, you're going to learn how to deal with setbacks. So that's another one, Andrew. People are really smart. When they fail, I teach them, I coach them on, knowing how to fail gracefully and recover back from devastating setbacks, an important skill. So for all my mentees from around the world, these are some of the things I'm actually, teaching them and having them also, reflect on what is success. If you look at Coach John Wooden, he summarized it this way. He said, success is the peace of mind that comes from knowing you did the best to be the best you're capable of becoming, right? So I help them to connect to that purpose, connect to the child within, recognize that when John Lennon said, imagine all the people living life in peace, right? Imagine a world where every peace-loving human has the opportunity to rise to their full potential and contribute in that direction, right? Suddenly, you become a part of a larger movement of humanity that's bigger than yourself. And when you do that, you've found your ikigai, right? The Japanese culture teaches you wake up in the morning, you're filled with energy. You can't wait to get up and go and run and do the best you can and repeat, in a new way the next day again. So you realize you live with a sense of urgency, not a single moment to lose, Andrew. Only the very best every single day. So in the end, I ask my kids when they come back from school, right? They come back and say, I got this grade. I said, look, grade is important, but let me first ask you, did you do your best? Second, did you learn something? Third, did you have fun? This is very, very important. You have fun. Now tell me what your grade is. Don't come and tell me this is my grade and I'm not going to be impressed with that. If you're doing your best and you're learning all the time, good or bad, and you're having a blast, a fun journey in the process, the grades will take care of itself. This is what I teach my kids. This is what I teach all the innovating mentees and having a wonderful time, working our way towards a thriving planet.
DP, this was phenomenal. Thank you so much for coming on the pod. It was our great pleasure to have you.
Andrew, as I said earlier, I still cannot believe that I'm here with you, right? This is Andrew represents to me, Jennifer, he represents the finest, minds on the planet. Him and Tim Burke, they're the fastest PhDs from Stanford, and I've seen how they work. They do their homework, and there's a clear difference, right? There is what you see on a daily basis, and what I see is pretty good work, right? IBMers and global foundries, that type of stuff, it sets a very high bar. But what I see, the people, innovators, the next generation coming along, Andrew and Tim Burke and the Arch team, what I see special in this team is they're doing the homework, listening to the customer, right? Listening to the customer and saying the things that need to be said. Give me the tool you're looking at. I'll tell you what the right data to look at is. Just once you hear that, doors open, and then to see them work like that, it inspires. Andrew, you inspire me.